Hello dear students. Let's revise the concept of two-dimensional array and pointers using a very simple program. In fact, it's like a quiz. Now you can see that in this program we have declared a two-dimensional array containing 3 rows and 3 columns named as A. And I have initialized it such that row 0 will store 10, 20, 30 correct 3 values. Row 1 will store 40, 50, 60, right? 3 values again. And row 2 will store 70, 80, 90, again 3 values. So this is initialization of 3 by 3 matrix. Just check. On paper, we can show this as this matrix has 0, 1, 2 rows and 0, 1, 2 columns and storing the values as shown from 10 to 90. Now I have assumed that row 0 starts at address 100. So obviously if row 0 starts at address 100, then row 1 will start at address 106. Why? Because as usual, we are going to assume that every integer consumes 2 bytes. 2 bytes. So obviously, if this row starts at 100, then 100, 101 for 10, yes, 2 bytes, 102, 103 for 20, and 104, 105 for 30. So obviously the next row will begin at 106, and similarly the last row begins at 112. But you all know that the matrix is not stored like this in the memory. It is stored as a continuous memory locations byte after byte. So I have shown 10 to 90 all values stored in sequence. And also I have again assumed that row 0 begins at address 100. So row 1 begins at 106. So row 2 begins at 112. Now, if you want address or base address of this one-dimensional array, recall what is two-dimensional array? It is collection of one-dimensional arrays. So if you want base address of this 0th one-dimensional array, you can simply write A0. Correct? If you write A0, you will get 100 base address. And what if you want base address of this one-dimensional array, which is first one-dimensional array? This was 0th, this is first. Simple, you just write A1 and you will get 106. Similarly, A2 will give base address of this one-dimensional array. So please try to understand, we are having 3 one-dimensional arrays. 10, 20, 30 is one-dimensional array, 40, 50, 60 is the other, and 70, 80, 90 is also a one-dimensional array. Okay? And you also saw that this notation is equivalent to writing asterisk A plus 0. This is equivalent to writing asterisk A plus 1. And this is same as asterisk A plus 2. Keeping all this in mind, now answer the few questions here. See, I am printing addresses over here. That's why I am using unsigned integer. I am not using %d, but addresses, as you all know, cannot be negative. So why do you use %d? %d is used whenever you are printing integer, and integers can be positive or negative, but addresses are unsigned. They don't have any negative or positive sign. In fact, they are always positive. So we use %u notation to print addresses. Now, which are the two values are we printing? A0 and asterisk A plus 0. Tell me what is A0 then? Referring our diagram, A0 is clearly, this is A0 is clearly 100, isn't it? And what is asterisk A plus 0? Oh, this is same as this notation. So the output produced due to this will be 100, again 100. This is nothing but base address of 0th row. Similarly, in the next printf, I am again printing two addresses. What is A2? Refer, A2 is nothing but base address of this one-dimensional array, which is 112. So this is going to give us 112. But what is the other notation written? It is same as writing A2, which will be also printing 112. base address of the second one-dimensional array, which is 70, 80, 90. Now the next thing, we are again printing addresses. You see 2% use have been written. So again address, what is this and A21? What I am trying to get, what I am trying to know is what is the address of second row first column. Just check second row first column. Now just see this diagram. This row, second row, but the first column. So this element 80, this one which I am marking, I want to know the address of this element and has to be 114 because you know that the row itself begins at 112. So address of 70 is going to be 112, but address of 80 will be 114, assuming that each integer consumes 2 bytes. Okay. So what is this going to print? I am again underlining this. Address of A21 is clearly 114. But just notice the next notation written here. Just check this. What do you understand from here? This is also 114. How come? Yes, we saw it in the earlier video that if you are writing A21, isn't it? What did we write? Let me refer. Yeah, A21. If you write A21 and address of this. Now, how do you write A2? A2 is written as asterisk A plus 2. But then you want to add 1 to it because you don't want begin address of row 2, but you want first column in that row. Now this entire notation is going to give address, This itself is address. So you may either write ampersand then A21 or simply write asterisk A plus 2 plus 1. Isn't it so? So both these things are going to give 114. This is address of second row first column. Now starts the fun part. I am again printing 2 addresses. Check. The first thing I am printing is A. Oh, this we never saw in the earlier video. We saw that A0 gives address of first array or rather 0th array. And it is same as asterisk A plus 0. Correct? But what does simply A mean? Just check. If you write simply A, that is the name of the 2-dimensional array, this also gives begin address of row 0. Simply writing A, if you for this entire diagram, if you simply write A, print A, suppose, then this is same as saying print A0. And you know A0 is nothing but address of row 0. So A will also print 100. Just remember this. Name of a 2-dimensional array gives base address of row 0. And what's the next thing we are printing? That's the same thing, base address of row 0. So both these will print again 100, 100. Please try to understand why we are solving this exercise so that various notations will be very, very clear and comfortable. Now, next line, we are printing integers. Clearly, we are printing values, not addresses now. So, A21 we are printing. A21 means value stored at second row and first column. And I think the value stored was 80. Yes, this is the value in the second row, first column. So, this first value is going to be 80. But you notice, this notation is also going to give you the same value, 80. Because we saw any such notation is getting converted by compiler in this fashion. So what is %d A00 going to print 10, correct? Row 0, column 0, and this clearly will also print 10. Isn't it so? Something interesting you find here. The last one. Check this. Asterisk A plus 0 plus 0. This is same as asterisk A plus 0 because A plus 0 is simply A. But this is same as asterisk A because anything added with 0 is the same thing. This is same as asterisk A. So if you write 2 asterisks followed by name of a 2-dimensional array, then you will get row 0, column 0 value. Don't get confused. I mean, there is nothing to confuse here. If you follow this simple rule, that means aij, value at ith row jth column, is same as asterisk asterisk a plus I plus j and the whole thing asterisk. Now what if this both were 0? Then both I and j are 0 and it comes out, it boils down to asterisk asterisk a. That's what I am saying, isn't it? Now this gives us a concept of pointer to pointer. We have been learning pointer, but two-dimensional array is not a simple pointer, but it is a pointer to a pointer, which we will come to that concept of pointer to pointer in the next video. Thank you very much.